Hello and welcome to Feilong, the open source API for ZVM automation. My name is Mike Friesenegger. I am a solutions architect at SUSE working on our partnership with IBM. Let me take a moment to explain what Feilong means. So in Mandarin, Feilong translates to flying dragon. I also found another reference that explained Feilong as a winged legendary creature that flies among the clouds in Chinese mythology. Well, Feilong, the project that I'm talking about today, isn't quite as cool as a flying dragon, but Feilong, the project, does work within the clouds. It provides infrastructure as a service automation. It provides an API for infrastructure service automation that then can be used for creating clouds on IBM Z and Linux One systems. At the core of Feilong is a RESTful API server that helps to simplify the interaction with the IBM ZVM hypervisor. The mission of our project is to contribute and further develop this RESTful API server. The benefits that we provide to the community through our project is, we've started with a really strong code base to use to contribute and further develop thanks to an IBM contribution to the project several years ago. The RESTful API server makes using ZVM much easier for developers that don't have deep knowledge of ZVM and its inner workings. And this all can be put together to enable development of self-service infrastructure service automation of virtual machines, network, and storage that are used by ZVM. Basically, summing it up, being able to create clouds on IBM Z and Linux One systems using the ZVM hypervisor. Here's some information about the Feilong project. Let's start where you can find more information about Feilong. You can go to openmainframeproject.org/projects/Feilong. If you want to take a look at the Feilong source code and build it or try it out, you can go to GitHub, openmainframeproject/Feilong. The README page for the Feilong project on GitHub has links to the documentation. I thought I put the documentation link here as well. Thanks to one of our sponsors within the Open Mainframe project, they have provided their Z system and a couple of ZVM environments that are available for project contributions. So anybody that wants to do development, testing, updating the documentation, and testing as they update the documentation, we have ZVM environments available for those contributors. Every month we have an hour-long meeting on the second Wednesday of the month at 9 a.m. Eastern, 3 p.m. Central European Time, and 9 p.m. China Time. Within the GitHub project, I try and make sure the meeting notes get uploaded and so anybody can actually go and check out what the Feilong project has been up to. This is the link to the Feilong meeting notes. And then also we'd like to stay connected. We try and do that through the mailing list, which is provided by the Open Mainframe project, as well as Slack for IM chat. Let's dive into the overall architecture of Feilong on this slide, and then over the next several slides, focus on each of the components that make up Feilong. The overall architecture can be summed up in three key areas. First of all, a REST API layer that is Python-based. It follows the standards for REST API, and that API then can be consumed by other technologies like OpenStack or VMware. The second layer of the architecture is a transition layer. It translates what is happening at the REST layer into what will happen at the bottom layer, which we'll talk about in a moment. But the transition layer also is Python based. It supports multiple threads, and it is called by the layer above. As RESTful API calls come into the REST API layer, the transition layer will take those calls and translate them into the SMCLI layer, or the ZHCP layer, which is completely written in C, and it works directly with SMAPI, which is the Systems Management API for ZVM. Now let's take a moment to dive a bit deeper into each of these three components. The REST API layer is implemented using a web server. That can be Apache or HTTPT or an Nginx web server. The web server will accept requests from HTTP clients. An HTTP client could be a web browser, or it could be via command line like curl, or most likely through some kind of programming language, whether that be Python or some other program that is able to talk the REST API language. REST stands for Representational State Transfer. And I know that's a long word, but basically it's pretty simple. The HTTP client makes a REST API call to a URL, and that URL points to the REST API server and passes some information. And in this example, it's doing a HTTP post to /servers/abc, and what that does, it will create a guest. Now there's some additional information that needs to be transferred along with that request, and that is done through JSON, and the program would actually pass some additional information to the REST API server, passing the HTTP post plus the JSON information, and then it would go off and hand it off to the transition layer. Because this is written in Python, the REST API layer and the integration with the Apache or Nginx web server is easy to extend, and it is API backward compatible for older versions of the implementation. Once the REST API layer has received a valid RESTful API request from an HTTP client, then it hands it off to the transition layer. The transition layer accepts the request from the REST API layer, and then it handles the logic processing. It determines what needs to be done, what image needs to be used, what vSwitch connections need to be created, what ZVM host is going to be communicated with to create a virtual machine in the previous example, and what virtual machines and how the virtual machines are going to be created. Once the transition layer has done its job, then it will go ahead and make a call to the lower layer, the ZHCP layer, which then will interact with SMAPI. The ZHCP layer will accept the request from the transition layer, and the ZHCP layer is the only layer that is written in C and has a C-based wrapper for SMAPI. The other two layers that we spoke about are both written in Python, but the C layer handles the requests and does things making sure that timeouts are taken care of, asynchronous IDs. If there's any errors from SMAPI, the C layer makes sure that it interacts properly with SMAPI and hands back any information to the upper layers as SMAPI does its job and it processes whatever that RESTful API call is. Let's take a couple of minutes to demonstrate Feilong in action. To demonstrate Feilong in action, I'm going to use the example that I spoke about before in one of the previous slides, where I'm going to go ahead and create a virtual machine. Now, to be able to do that, I've chosen to use curl as the HTTP client that will send the request to the web server, the RESTful API web server, and it will go ahead and Feilong will interact with the ZVM directory to create the user. To prepare, I have to create this JSON file, and as you can see in the JSON file, I'm going to create a user called VM01 that has one virtual CPU, 1 gig of RAM, and it has a 1 gig disk. I'm not going to really install anything in it, but this is going to be a simple example of how Feilong works. Let's go ahead and let's make sure that the directory does not have a VM1 user. And as you can see, VM01 does not exist in the directory. This is the 3270 console. Okay, let's put the 3270 console away for a moment. Now, to see Feilong in action, there's a process that's running on the system where Feilong is running, and that process is called SDK server. And as you can see, I've got the SDK server running here. So we're going to watch the SDK server process. And we're going to kind of just watch that in the background as I run some of these commands and things like that. So now let's go back over to the other terminal window. And let's start interacting with Feilong. We're going to do some simple things first. We're going to do a curl, and we're going to make an HTTP request to the local host where Feilong is running, and we're just going to get some information about the Feilong system itself. And as you can see, the Feilong version that's running here is 1.4.0. All right, let's go ahead and use that command and just extend, and let's look at what guests Feilong is managing on this system. And as you can see, the output shows nothing. So at this point, Feilong is not managing any guests in this ZVM system. Well, let's change that. Let's go ahead and create a guest. So to do that, I'm going to copy this curl command. All right, so let me explain what's happening here. So we are going to post an HTTP request, and it's going to be of content type JSON, and here's the JSON file that I showed you just a few moments ago, and we're going to actually post it to the Feilong server, and let's see what happens. Now as I press enter here, watch the back screen, and you'll see some things happening as the SDK server receives the request and then does things. So you can see in the back it's creating an image, it's creating a disk, and it's bringing everything online. It's taking care of formatting the DASD. I'm actually utilizing a DASD disks for this configuration. Feilong can work with both DASD devices and fiber channel devices, and it's done. As you can see, the response, the JSON response, proves that it was successful. So now let's just go back and let's look at the guests, and now you can see that the VM01 guest is being managed by Feilong. Well, let's go ahead and look at it slightly different way, and let's go back over to the 3270 console, and this time let's run that exact same command. Now we don't get an error message that the VM01 doesn't exist. Now we can actually look at VM01. Now if you noticed, if I was a developer, I didn't have to really do anything with ZVM. I was able to utilize curl commands or web RESTful API requests. But as you can see, The VM01 guest has been created. I can see that inside of the 3270 console using the durmate commands, the durm commands, and it worked. It worked. Great. All right, so let's go ahead and finish up this demonstration by going back to the terminal, and let's delete this user. And again, in the background, watch the SDK server. And you can see it's doing an image delete. And in a moment, the delete should be done. And it's done. So now if I go back and look at the guests, no guests are being managed by Feilong. Now that you've seen a simple demonstration of Feilong in action, you can see that it's quite technical. And it's infrastructure. It's a lot of code. It's a lot of stuff that no end user is ever going to see. Let's take a moment in this slide to talk about the reference architecture and then follow it up with a demonstration of something that end users will understand. How does Feilong help me and help an end user do something that's important in their job? Well, as you can see, Feilong is in purple, listed as number 2 here in the slide. Again, infrastructure, very technical, helps in automation. Most end users will never touch Feilong directly. What they will do is they'll use some kind of tool that sits on top of Feilong and interacts with Feilong, making the RESTful API calls. And in this case, that's what is in number 1, OpenStack. OpenStack will actually be the tool that end users can use to interact and create and work with virtual machines. OpenStack will communicate with Feilong. Feilong will then in turn communicate with ZVM, creating the virtual machines, adding the networking, adding the storage and things like that. But the end user will never know any of that's happening under the covers because they're going to be interacting with OpenStack. Let's go ahead and take a look at that. You're looking at a web browser, which is connected to an IBM product called IBM Cloud Infrastructure Center. Under the covers, IBM Cloud Infrastructure Center is OpenStack. We're going to utilize this web-based interface as if we are an end user to create a virtual machine, and we'll demonstrate how OpenStack through IBM Cloud Infrastructure Center communicates to Feilong to create that virtual machine. So before we start doing things on the web browser, let's go back to the terminal window that you were used to seeing before, and let's look for our SDK server, because the SDK server is running in this configuration as well. So let's go ahead and start our watch command to watch the SDK server. All right, so now we're going to go ahead and go back to the web browser, and let's create a virtual machine the way an end user would. So we're going to go ahead and deploy a SLES 15 SP2 image. And I've already filled out most of the information just to speed this up, but it's going to be VM01 and some additional information. Let's go ahead and start the deploy. And the deploy has begun. Now let's not watch the deploy because that's kind of boring. Let's go over and watch what's happening behind the scenes. An image is being created. A disk is being created. And the disk is being brought online, and it's being formatted. So many of the same things that we saw in the previous demonstration, the more technical demonstration of Feilong, is now being done the same here, but I'm not issuing curl commands. I'm actually utilizing a web browser like an end user would. And now we're going to wait and we're going to watch as this completes. Now, through the beauty of technology, I'm going to go ahead and speed up the rest of this so we don't have to wait several minutes for the image to be deployed and the virtual machine to be brought online. Now, if you're watching very closely, you can see that OpenStack had Feilong do a lot more stuff. But let's go back to the web browser now, and we can see in the lower right-hand corner that the deploy of the virtual machine was successful. If I go over to virtual machine, I have some information about it. Let's go ahead and copy its IP address. And let's go back to the other tab here, and let's paste in that information. And we're still waiting for the system to boot up. It's now available. And if I do, I am now connected to the virtual machine. Now, again, this is how an end user would do things. Very much more cloud-like. Deploy a virtual machine, connect to it, and start doing whatever they need to do. So what's next for the Feilong project? One of the big goals for this year is to graduate from incubation status to active status. We have a great project. We have a great group of people that are part of the project. We have active contributions to the project. We have all the pieces in place for us to get from incubation to active status. We have to do the work to document why we should become active status and what we are doing to be an active project within the Open Mainframe project. One of the other things I'd like to tackle, but I need help from other contributors, is updating the documentation. The Feilong documentation that I pointed to earlier in the presentation is good, and people can get started with it, but it needs to be cleaned up. It needs some updates. We're always interested in sponsoring the OMP Summer Mentorship project when it relates to Feilong, so we'll be looking at that. And then this is something I like to do all the time, but increase our Feilong membership and increase the number of people that attend our regularly scheduled project meetings. So with that, I hope this presentation and demonstration has been helpful for you to learn a little bit more about the Feilong project. And if you're interested, love to have you join one of our monthly meetings and become a project contributor. If you have any other questions, please reach out to me through the mailing list or through Slack or through the Open Mainframe project website. Thank you. Have a great day.